Hey, hello there, GH101. We are doing yet more examples in our programming. These are classic beginning of programming examples because you want to get the classic genuine experience. Some of these examples are not really what you would use R for, but we're doing beginning programming, so this is what we're doing. I'm going to do now another one that is, we'll do bottest.r. Okay, so what I want to do with this one is challenge the user of this program to see if they are a bot. Okay, sort of like CAPTCHA, if you've seen those or other such. So you're on a website, you're going to submit a form, and the website says, wait a minute, what does this picture look like, to make sure you're not a web bot submitting the form just automatically. Alright, so what I'd like to have is something like the program asks the user something, and I'm going to ask, since we've been doing math stuff, I'm going to have two numbers, x and y. Ask if what is x plus y. Okay, so I'll have some variable x, let's just say 14. I'm going to have some variable y, let's say 7. Alright, so I'm going to say, let's see, hey there, what is, I'll even put it like this, so they have to know something about programming. No, I'll put it like, alright, what is x plus y. Alright. Here you may have noticed I used double quotes. Don't think that's in our list of punctuation. For your purposes right now, double quotes and single quotes are the same. So specifying a string in programming, text is called a string. So you use two single quotes with stuff in between or two double quotes with stuff in between. That's two left quotes, but in the programming it's just double quotes. Alright, so I'm going to go ahead and test this to make sure it works. Hey there, what is 14 plus 7? Awesome, that's what I wanted. I want to make a note here in terms of our basic programming concepts. I'll call this incremental development. Get the smallest part of the program you can think of. Put that in, test it, make sure it works, and then next smallest. Right, so you always want to be testing your code as you type things in that it works. All right, so at least I've got this part all right. Now I want them to tell me something, and there's a function that I don't think is in the cheat sheet or the tutorials point, because this is not something you normally do in R, but we're going to because it's fun. All right, so their let's see, their guess, let's say, is readline. So there's something called readline, and I have a question for you. If I wanted to look up the help on readline, how would I do that? Like this. So, like that. Or you could go over here in the help or ask Google. All right, so then I want to make sure that I actually got their guess. You said, all right, then guess. Let's go ahead and run this. Hey there, what is 14 plus 7? And it's sitting there waiting for me to type something. Let's say I typed 21. You said 21. All right, awesome. Now I want to test if they're correct. So I'm going to use my if, and then what do I want to use to test if they're correct? So I want to, if correct, say correct, else say wrong. All right, that's what I want to do. What do I need to type? You can pause and think about it. All right, so what I want is x plus y, right? I have these in variables. The program can do that, x plus y. So I want to say if x plus y equals guess. So if they're correct, there's going to be a couple mistakes here. So if you think I'm making mistakes, then that's good because, all right. So I'll say correct, and otherwise print wrong. Okay, it's already it's giving me the red X. And if I try to run it, it says unexpected equal. And this is so common a mistake and misunderstanding that it deserves to go on our basic programming concepts. So variable assignment is not equal to checking equality. And that actually gets to be bold because everybody gets to make this mistake. Okay, so there's two different things that you would want to use the equal sign for, and one of them is z equals 2. So that is called variable assignment. I put a value into z, and in R you can do that with equal or with less than dash. Either way, it does the same thing. There's reasons to prefer this in terms of the style of the program, so that's what we'll do. But if you type equal, that does the same thing. Up here, I want to test if these are equal. I don't want to actually save a value into x plus y. That doesn't make any sense. X plus y is an expression, not a variable. All right, so to do checking equality, typically in programming, you do two equal signs. That's the rule in the programming language. Okay, so I could say here, z equal 2. What do you think will print? True. All right, that's one of our comparison operators. It's actually on our list over here of comparison operators. Equal is there for testing equality, not just equal. So saving into a variable was less than dash or equal. Just a single equal like that. All right, let's run this now and see what it wants to complain about. It doesn't like the else because not sure, so let's just see what happens if we get rid of the else. Hey there, what is 14 plus 7? It's waiting for me to type down here, 21. You said 21, it says correct. It still doesn't like things, but I'm going to make a note over here of basic programming concepts. Debugging, let's say incrementally, let's see, or debugging by let's get back to basics. Okay, so debugging by let's get back to basics. Trademark. So you remove, let's see, your program doesn't work. So what do? Comment out almost all of it. Make sure the first part works right. If yes, uncomment a little bit. If no, what's wrong, right? So if no, what's wrong, you've narrowed down where the problem could be. So that's what I've done, is comment this stuff out. At least I know that the first part probably works. And I could test that on different things as well, to at least know that it thinks I have a syntax error. But at least I don't up till there. Let's say I say 22. And it just says that I said 22. It doesn't say correct. All right, I'm going to pause here and stare at this for a second. Debug by staring. Okay, staring complete. I'm used to programming in other languages where this would be okay, but it's not here. I just looked at my cheat sheet at an example of what they have for if-else. So this is their if-else. So if condition is something, then you have the curly braces, do something inside, and then we have the else. And I noticed that else is on the same line there. So let's put it up here. And now the red X goes away. Let's type in 22. And it says wrong. That's super awesome. And correct. All right. So this was, I'll put it under our basic programming concepts. So debugging or developing by, so this technique is called find a similar example when we're doing basic programming. Okay, so this was in my, I won't write anything there because that already says enough. If I went to the cheat sheet, but the next step might have been to search Google for R if else, or go to your tutorial, right? Tutorials point that I was telling you to read, go back to the if else. Okay, I want to make this, give them a couple of chances. So I'm going to do this whole thing, and what I would like to do is say, let them do this until they succeed. So for that, I'm going to have a logical Boolean variable that says you pass the test. Initially, that's going to be false. You have not passed the test. And I want to do all of this as long as they haven't passed. And we're going to use the while loop for this. So the while loop, let me get all this in. And then what a while loop does, it's kind of like a for loop. The for loop, if we look at our base R example, so for in between parentheses you have something like this, and then you have your whatever happens in the curly braces. So the while has, instead of something like this, we have some condition that's either true or false. And as long as the condition is true, we're going to do what's in here. Okay, so in our example over here, I want to have a true-false variable that I'm going to set whether they pass the test, yes or no. Initially, I haven't asked them anything, so it's going to be false. And then down here, I just want to update that depending on whether they pass the test or not. So what should I change in my code here? Let's run it the way it is first. Hey there, what is 14 plus 7? Let's say I say 55. Wrong. Now it asks me again, and so I'll say 21. It's asking me again. It's still asking me because I never actually changed this value. And the thing that I needed to do was, if they're correct, update that. Now how do I make this stop running? Try Control C. Control D. Control kill the program. Let's pause. Okay, so I'm not seeing how to kill that based on what I have right now, so we're just going to close our studio and open it again. Am I sure I want to quit? There's probably something I could. I'm just going to quit. Save the workspace. So what it's asking here is, do I want to save all the variables in my console history? It actually doesn't matter because I have everything in my scripts up here, so I'm not going to save that. Let's go ahead and open back up and fix that. And it doesn't remember, it does remember I had my files open. Excellent. And I still have my code, but I need to do past test is true. Let's try to run it again. 21, you said 21, correct. All right, what if I wanted, instead of 14 and 7, I want to have some, random, it picks some random values. So I'm going to go to the Ask the Internet, R programming random integer. And typically the first couple results, one of them will have an answer that makes sense. So we can try this one. Let's try sample. There's probably many different ways to do this. Let's actually look at sample.int. Okay, so this is looking at help on this sample.int function, or the sample function. So sample.int, number of items to choose from. Number of items to choose, there's lots of stuff. Let's look down at their examples. we could read this. I'm going to skip to the examples. Random permutation, no, that's not what we want. Where's the random.int? Or sorry, sample.int. So this is a billion, and then there's a 12. Looks like they're taking, let's say, 101. So that's a single number between 1 and 100. If I did a 2, I would get 2 numbers. I don't want to do that right now. So I want to do, let's say, sample.int something up to 20. One thing. Sample.int something up to 20. But I want to see if the rest of my code is going to still work the same. Let's say x sample.int. Okay, there's x. There's y, x plus y. 17. Let's say I want to do a read line. So guess is read line. And let's say I type 21. Does 21 equal x plus y, yes or no? What do you think? It does not. So what is x plus y? It was 17. All right, 17 does. What about guess? What is guess? 21. What is the class of guess? Character. What is the class of x plus y? Integer. So we have x plus y is 17. Guess is, did I guess 21? Right, so let's do that again. Guess is read line. 17 is what we're supposed to say. All right, it's true. So that looks like the code we have is going to work, which you might expect. Let's run it and see what happens. Okay, so it just says, what's 11 plus 9? And let's give a wrong answer first. Let's say 11. Wrong. And it doesn't ask me the same question again because every time it goes through the loop here, it picks x and y, it runs this line again, and every time it runs this line, it's going to pick a new random integer. What's 5 plus 12? 17. Correct, and it let me through. Isn't that exciting? All right, there's another example. We learned some stuff, I think. Let's see, we should make note that we have a function called readLine if we want to do a program like this, which you don't often actually do with R, but readLine. The sample.int is something that we may decide to use in the future. And so what I think we'll do at this point is, if you've been watching these videos straight through, we have a bunch of examples. We've taken some notes on some basic features. You go back and check the base R cheat sheet again. You go and read through some of the tutorials points stuff. And then I think we'll do a couple more basic programming concept stuff so that you can sort of get a vision in your brain of how this stuff is working. So flowcharts are yippee, exciting ways to have pictures about programming. the structure, so pictures of the structure of your program, and maybe some other, let's do play computer. So this is another thing that you have to do, which is debugging by play computer, trademark Rob Sternfeld. So those are things that we'll do that will hopefully help you understand what's going on. Those will be coming pretty soon then. Okay, so for now we will say happy programming.